And I'm going to use the variable t when I set this up. Okay, t to represent time. Okay, so this is exponential function. It's a function of time. Right? Population is a function of time. Right, and so here's what the different elements of the exponential function mean when you go to modeling. So the t, or the exponent, is your time. Generally in years, but when you're talking about like radioactive decay, it might say like seconds or minutes or something as well. So like it's some time unit, usually going to be years. And if it's not specified, it's probably like years. Okay, A is still going to be your what? A represents the initial amount. Okay, and so that's going to be true here as well. Okay, it's whatever the starting amount was. B is where it gets sort of that tricky. Okay, so B is going to be your growth factor. Okay, and what B is going to represent is it's 1 plus R or 1 minus R. So this is growth. This is decay. Okay, where R is the rate as a decimal. All right, so based on this information right here, you can create a function for the problem that's given. Okay, so it says the population of a country in 2012 was 4.64. So I have 2012, 4.64. Okay, so if I was setting up sort of ordered pair, there's my input, my corresponding outputs. Okay, but this is where I'm starting, right? So I'm not using 2012 as my x, my input. What I'm saying is I'm going to start with this amount. So what I want to do is I want to think of this as 0 and 4.64. Okay, so there is my initial amount at time 0. I'm letting 2012 be time 0. Right? So this was xy. Okay, this is t and then p of t. Again, the difference between those is I want my population as a function of time. So at time 0 in 2012, my population is 4.64 million. So what's the t value going to be? What's the other set of coordinates that I have for this? Well, so I want to solve for that, right? I don't know what it is, but I do know that I'm dealing with 2021. Okay, so what would my t value be for 2021? 9. Right, so my time 0 was 2012, so 2021 is going to be 9. So I know that. And then my answer is going to be this value here. So this is what I'm looking for my solution. Okay, so what I can do now is I can go back into this form right here and create an equation. So I can say that P of t is equal to my initial amount, which was what? Here's my initial amount, 4.64, times my growth factor. So here is this growing or decreasing? Growing. So it's 1 plus 9.5% as a decimal would be. Okay, so I'm just going to call it 1.095. Okay, so there's my 9.5%. And then my t value is what? 9. And so this is going to give me my new number, my solution. And so when I calculate this, I get my answer 4.64 times 1.095 to the power of 9. Hit enter, and I get my solution of 10.50 approximately. It's in millions. Okay, but that would be my solution.